DSL, Digital Subscriber Line, is a family of technologies used to transmit high-bandwidth digital data over traditional copper telephone lines. Collectively known as XDSL, these technologies allow high-speed internet access without interfering with standard voice calls. Types of XDSL. The X in XDSL represents various specific implementations that differ in speed, distance, and symmetry. ADSL, asymmetric DSL, the most common type for residential use. It provides higher download speeds than upload speeds, matching the behavior of most home users. ADSL 2/2+, enhanced versions offering faster speeds, up to 24 Mbps, and better range. VDSL, very high bitrate DSL, offers significantly higher speeds, up to 52 to 100 Mbps, over very short distances. VDSL2, supports up to 200 Mbps aggregate speed using advanced techniques like vectoring to cancel noise. SDSL/SHDSL, symmetric DSL, provides equal upload and download speeds. This is primarily used by businesses for applications like hosting servers or video conferencing. HDSL, high bitrate DSL, an older symmetric standard used as an alternative to T1 lines, typically requiring 2 or more wire pairs. G.fast, the newest major standard, capable of delivering fiber-like speeds, up to 1 Gbps, over extremely short copper segments, under 100 meters. Key technical features: spectrum utilization. DSL uses frequencies above the 4 kHz used for voice, allowing simultaneous phone and data use. Modulation. Modern DSL primarily uses discrete multitone, DMT, modulation, which divides the line into multiple smaller channels to maximize data flow. Vectoring, a noise cancellation technology used in VDSL2 to reduce crosstalk between adjacent copper pairs, significantly increasing speed. Always-on connectivity. Unlike legacy dial-up, DSL maintains a permanent connection to the service provider. Advantages of XDSL: cost-effective infrastructure. It utilizes the massive global network of existing copper telephone lines, avoiding expensive new cabling projects. Simultaneous use. Users can talk on the phone and browse the internet at the same time on a single line. Dedicated connection. Unlike cable internet, DSL provides a dedicated line from the home to the exchange, meaning speeds are not typically affected by neighbors' usage. Widely available, because it relies on phone lines, it reaches many areas where fiber or cable have not yet been deployed. Limitations of XDSL: distance sensitivity. Speed and signal quality degrade sharply as the distance from the provider's central office or cabinet increases. Bandwidth ceiling. Even advanced versions like G.fast cannot match the long-term scalability of fiber optics, which can reach 10 to 100 Gbps. Susceptibility to interference. Copper lines are vulnerable to electromagnetic interference and physical degradation, example moisture in lines. Copper phase out. In 2025, many major telecom providers are actively retiring copper networks in favor of full fiber, FTTH, infrastructure. Distance and speed in DSL. In DSL technology, the relationship between distance and speed is an inverse one, as the physical distance between your home, the modem, and the service provider's equipment, the DSLAM, increases, the maximum possible internet speed decreases. This is the primary reason why two houses on the same street might have vastly different internet speeds. The physics. Why does speed drop? The signal travels over copper telephone wires, which were originally designed only for low-frequency voice calls. High-speed data requires high-frequency signals, which face two major physical hurdles: attenuation, signal loss. As electrical signals travel through copper, they lose energy due to the natural resistance of the wire. This is measured in decibels, dB. The longer the wire, the fainter the signal becomes by the time it reaches your modem. Electromagnetic interference. Noise. Copper wires act like antennas, picking up noise from power lines, appliances, and even other DSL lines in the same bundle, crosstalk. The signal-to-noise ratio, SNR. To maintain high speeds, the signal must be much louder than the noise. As you move further away, the signal gets quieter, attenuation, while the noise stays the same. Eventually, the modem can't distinguish data from noise, and it must slow down to stay connected. Speed versus distance comparison. The impact of distance depends heavily on the specific DSL technology being used. Distance from DSLAM. ADSL2+ max speed. VDSL2 max speed 300 m, 0.2 miles, 24 Mbps. 100 plus Mbps 1 km, 0.6 miles, 18 Mbps. 50 Mbps 2 km, 1.2 miles, 12 Mbps. 15 Mbps, drops sharply, 4 km, 2.5 miles, 4 Mbps likely unavailable. 5 km plus, 3 miles plus, 1.5 Mbps or no sync unavailable. VDSL2 is like a sprint. It is incredibly fast but only over very short distances, usually under 1 km. ADSL2+ is like a marathon. It is slower overall but can maintain a usable connection over much longer distances, up to 5 km or more. Why the DSLAM matters here. To fight this distance problem, ISPs often move the DSLAM out of the central office and into small green cabinets on street corners. By bringing the DSLAM closer to your house, they shorten the copper loop and can offer you much higher speeds, like VDSL2 or G.fast, that wouldn't be possible if the signal had to travel miles from a central hub. Summary: in 2025, XDSL remains a critical bridge technology that provides affordable broadband to millions, particularly in rural and underserved areas. While it is gradually being surpassed by fiber to the home, FTTH, advancements like VDSL2 vectoring and G.fast have significantly extended the lifespan of copper networks by offering competitive high-speed performance over the last mile. Splitter in DSL. In a DSL, digital subscriber line, system, a splitter is a critical hardware component used to separate voice and data signals that travel simultaneously over the same copper telephone line. Primary function, signal separation. Because DSL uses different frequency bands for voice and internet traffic, a splitter acts as a gateway to ensure each signal reaches the correct device. Voice, low frequencies. Traditional telephone service, POTS, operates at low frequencies, typically between 300 Hz and 4 kHz. Data, high frequencies. DSL internet signals operate at much higher frequencies, usually starting at 25 kHz and reaching up to 1.1 MHz, for ADSL, or 30 MHz, for VDSL2. How the splitter works: the device contains two types of internal filters. Low-pass filter, this blocks high-frequency data signals but allows low-frequency voice signals to pass through to the phone port. This prevents you from hearing hissing or digital noise during a call. High-pass filter, often built into the modem port, this ensures that low-frequency telephone noise does not interfere with the high-speed data transmission, maintaining internet stability. Types of DSL splitters: central splitter, installed by a technician at the point where the phone line enters the building, the NID. It splits the signal for the entire premises, allowing one dedicated jack for the modem and multiple jacks for standard phones without individual filters. Customer installed splitter, Y-splitter, a small plug-and-play device that plugs into a single wall jack. It has one input for the wall and two outputs, one labeled phone and one labeled DSL/modem. Microfilters, simplified versions of a splitter used when you only need to connect a phone to a specific jack. They filter out the DSL signal for that individual phone but do not provide a data port for a modem. Why use a splitter? Simultaneous use. It allows you to use the internet and make phone calls at the same time without the signals conflicting. Interference prevention. Without a splitter, the high-frequency DSL signal can cause audible noise on the phone, and telephone activities, like picking up the receiver, can cause the DSL modem to disconnect. Signal strength. By properly separating the signals, the splitter ensures the modem receives the strongest possible data signal rather than wasting energy in the phone circuitry. Design requirements for DSL splitters. Design requirements for DSL splitters, including master splitters and microfilters, ensure that high-frequency data and low-frequency voice signals do not interfere with each other while maintaining the integrity of the traditional phone service. 1. Frequency response and filtering. Voice band, low-pass filter. The splitter must allow frequencies from 300 Hz to 4 kHz, POTS, to pass with minimal attenuation. DSL band, high-pass filter. It must provide high isolation, often greater than 55 dB above 25 kHz, to prevent DSL signals from leaking into the telephone handset. VDSL2 support. Modern splitters must support a bandwidth up to 30 MHz to accommodate VDSL2 Profile 30 high-speed services. 2. Electrical and voltage handling. DC voltage transparency. The splitter must pass standard POTS DC voltages, typically 0V to 72V, without degradation. Ringing voltage. It must withstand and pass high voltage ringing signals, typically 40V to 80V RMS at 15 to 68 Hz. Loop current. All technical requirements must be met while carrying standard loop currents, often up to 100 mA or higher for business lines. DC resistance. To avoid weakening the phone signal, the series DC resistance should be very low, typically 25 ohms or even 100 ohms depending on the standard. 3. Signal integrity and performance. Insertion loss. The loss in the voice band, at 1 kHz, should be negligible, typically less than 0.3 dB to 1.5 dB. Return loss. To prevent echoes and signal reflections, the splitter must match the characteristic impedance of the line, example 600 ohms or 900 ohms. Longitudinal balance. This measures the splitter's ability to reject noise from external electromagnetic sources. Requirements are often greater than 70 dB to ensure a clean signal. Isolation. During on-hook/off-hook transitions, the splitter must protect the DSL service from sudden impedance changes and ring trip interference. 4. Regulatory and physical standards compliance. Design must follow international and regional standards, such as ITU G.992.x, ADSL/ADSL2+, G.993.2, VDSL2, and ANSI T 1.413. Operating conditions. Most splitters are designed to function in temperatures ranging from -40 degrees Celsius to +85 degrees C to support outdoor cabinet installations. Physical interface typically requires standard RJ11 ports or gel-filled insulation displacement connectors, IDC, for reliable wire contact. Importance of splitters in DSL telecommunications. Splitters are vital because they allow high-speed data and traditional voice services to share the same copper wire without degrading each other's performance. Their importance is categorized into three main areas: 1. Preventing signal interference. Voice protection. Without a splitter, the high-frequency DSL signal, up to 30 MHz for VDSL2, would be audible as a persistent hiss, static, or humming on a standard telephone handset. Data integrity. Voice activities such as picking up the phone receiver, dialing, or a phone ringing generate electrical transients. These sudden changes can cause data errors or a complete loss of the DSL internet connection if not filtered out. 2. Optimizing network performance. Signal strength. Splitters ensure that the full energy of the DSL signal is directed to the modem. Without one, a significant portion of this energy is wasted or absorbed by the telephone equipment, potentially having the signal strength received by the modem. Eliminating echoes. The connection between a phone and a line often creates an impedance mismatch. At the high frequencies used by DSL, this causes signal reflections, echoes, that further degrade internet speeds. A splitter prevents these mismatches, maintaining a clean data path. 3. Reliability and service stability. Simultaneous operation. They enable the most basic requirement of modern DSL, using the internet and talking on the phone at the same time on a single line. Security and stability. In 2025, modern splitters also incorporate ME suppression and surge protection to safeguard sensitive equipment from voltage spikes and electromagnetic noise. Vectoring support. For advanced services like VDSL2 or G.fast, high-quality splitters are necessary to handle noise cancellation, vectoring, protocols that provide fiber-like speeds over copper. Summary of impact feature. Without a splitter. With a splitter, phone audio static and background noise crystal clear. Voice internet speeds low, unstable, or dropped. Calls optimized and consistent. Connection drops when phone is used. Stays active during calls. Equipment vulnerable to high frequency stress protected and isolated.